All right, let's look at the homework 9, problem number 11. So let's look at part A. All right, so we have a function f from a to b and the function g from b to c. All right, so it says that if composition g of f is 1 to 1, then f must be 1 to 1. All right, so let's look at that. So part A, so proof, we want to prove of part A, so proof of A. Alright, so let's start with, so since we want to show that f is 1 to 1, so here, this is what we want to show. So we want to show that if f of, say, a1 is equal to f of a2, then this has to guarantee that a1 is equal to a2. Right? So that's what we want to show. Right? So let's start with this. So we can probably say choose any, say, a1 and a2 in A, such that f of a1 is equal to f of a2. Alright, so if f of a1 and f of a2 are exactly the same thing, if you apply g to it, so say g of f, let's see, g of f of a1 is equal to g of f of a2, because you're basically plugging in exactly the same thing. Alright, then, but we know that the g of f is 1 to 1. This implies that a1 must be equal to a2. Right, so this is since g of f is 1 to 1. Right, so therefore we could show that a1 equals a2, therefore f is also 1 to 1. Right, so that's the proof of part A, so it's fairly simple. And the part B, we need to disprove that g of f is 1 to 1, then g is 1 to 1. Right, so in order to disprove this, we just have to come up with a counterexample where g of f is 1 to 1, but g is not 1 to 1. Right, so here's we want to do a disprove. I don't know if disprove is a word of B, I meant. Alright, so let's do that. So here's an counterexample. So we just have to kind of draw a picture. And so we have, let's say you have 3 sets, right? So you have A in the beginning. So this is a set A. And we have a set B. And then we have a set C. Right. So here's the counter. We are trying to come up with a counterexample. So G has to be non-1 to 1. So which means that you have to have at least 2 things. So here's maybe B1 and maybe B2. Right. That is mapped to just one element C. Right. So we have here this going here to C, and then going to the same C. So you can see that G, right? So this is definitely not 1 to 1. All right. Then, but we want to make the composition a 1 to 1. So we can probably try to make it as simple as possible. So here's A, right? So maybe G could just, F just could map A to say B1. So this is F. Right? So you can see that here, if you look at the composition, G of F, so you use F and the G, it's going to be 1 to 1 because A is simply mapped to C, right? But if you look at the G is not 1 to 1, right? So here's a counter example here. Maybe I should say counter, whoops, example. Right. So F is simply just F is just the from A mapped to B, and that's it. And G is B1 is mapped to C, and also B2 is mapped to C, right? So you can see that this is not 1 to 1, but if you do a composition, G of F is simply A is mapped to B1, B1 is mapped to C, right? This one is 1 to 1, right? So that will disprove that if G of F is 1 to 1, then G is 1 to 1, because this is an example where it's not. G of F is certainly 1 to 1, but there's a case where G is not 1 to 1. Alright, that's it. I hope that this was clear.